Hello everyone, this is Jennifer. So in this video we're going to do our next chapter, which is matrices. So what is a matrix? A matrix is a rectangular array of numbers, symbols or expression which basically are arranged in rows or columns. Okay, so the numbers that form a matrix are called the elements of a matrix. For example, if this is a matrix, the numbers inside this, that is 1, -2 and 3, are known as the elements of matrix. So matrix is basically an arrangement of numbers in the form of rows or columns. So this is a row and this is a column, which are basically enclosed with a pair of brackets. Okay, so the order or dimension of the matrix is the ordered pair having a first component the number of rows and the second component the number of columns in a matrix. For example, if you see this matrix, so in this matrix the number of rows into number of columns is nothing but the order of the matrix. So here the number of rows is 1, the columns are 3, so 1 into 3 is the order of the row matrix. If you take the example of this second one, which is column matrix order, so it is 2 rows and 1 column, so 2 into 1 is the order of the matrix. So the different types of matrices are: the first one, row matrix. So row matrix, a matrix consisting of a single row, is called a row matrix. So if you see here a matrix which is consisting only of one row, so the order of matrix here is 1 into 3. The column matrix, a matrix which having a single column. So here if you see there is only one column, so what is the order of this matrix? 2 into 1, so rows into columns. The third type is zero matrix. So zero matrix is a matrix wherein each element is 0 or is a null figure. So zero matrix are generally denoted by the term 0. This distinguishes zero matrix from the real number matrix. So every element in the matrix is 0. Rectangular matrix. So a rectangular matrix is a matrix in which the number of rows is always not equal to the number of columns. So if you see here, how many rows do we have? 3 rows. And how many columns do we have? 2 columns. So always the number of matrix is not, number of rows is not equal to the number of columns. Here the order of the matrix is 3 into 2. So now if you see the square matrix, square matrix is a matrix having the same number of rows and the columns. Okay, so the number of rows is always equal to the number of columns, either it is 2 into 2, 3 into 3 or 4 into 4 in the same way. Next is your diagonal matrix. So a diagonal matrix is basically a square matrix. So these are the types of square matrix. So it is a square matrix in which all the elements are 0 except the main or principal diagonal. So if you see the diagonal, only the diagonal will have elements, other elements will be equal to 0. So only the diagonal will have the real numbers, the other elements will be equal to 0. If such a matrix is there, then it is called a diagonal matrix. Next is a scalar matrix. So a scalar matrix is a matrix in which all the diagonal elements are same. So if you see all the other elements are equal to 0, the diagonal elements are same. So if 5, 5 and 5, they are same. If they are different, then it will be a diagonal matrix. So next is identity matrix. Identity matrix is a type of scalar matrix in which each diagonal element is equal to 1. So if the diagonal elements are equal to only 1, which is the number 1, then it is called as identity matrix or unit matrix, which is equal to unity 1. Okay, next is symmetric matrix. So a symmetric matrix is a square matrix wherein the symmetric of A is equal to A dash. So when A is equal to A dash, then it is called a symmetric matrix. A dash is nothing but when we change the number of rows and the columns elements, then also we get the same matrix. So when A is equal to A dash, then it is called a symmetric matrix. Skew symmetric matrix is a square matrix A wherein the diagonal elements are equal to 0. So when the diagonal elements are 0 and the opposite elements are equal, then it is called a skew symmetric matrix. So these are the different types of matrix. Now we'll move on to the operation of matrices. So operation of matrices. Now addition of matrix. How basically we will do the addition of matrix. So let the first matrix be A and the second matrix is B. So the resultant figure will be A plus B. So 1 plus 3, 4, 2 plus minus 1, which is 1, 0 plus 4, 4, 1 plus 2, 3. This is how you're supposed to do the addition of matrices. Subtraction of matrices. So same way, you just minus one digit with the other digit, looking into the order of the matrices. So when when you're doing subtraction of matrices, you should have the same order of the matrices. Okay, so 2 minus 1 is 1, minus 1, 0 is minus 1, 5 minus 2 is 3, 3 minus 1 is 2. Now your scalar multiplication. So scalar multiplication, so basically when you are multiplying one single digit with the matrix, then you get the resultant figure to be a scalar multiplication. So basically 6 into 2, 12, 6 into 1, 6, 6 into minus 1, minus 6, 6 into 8, 3, 18. So 6 3s are 18. So basically you are multiplying the digit which is outside into the matrix. 6 2s are 12, 6 1s are 6, 6 into minus 1 is minus 6 and 6 into 3 is 18. So next is your matrix multiplication. How basically you are supposed to multiply a matrices. So the product of two matrices is defined only when the number of columns of the first matrix is equal to the number of rows of the second matrix. So if you see the order of the first matrix is 2 into 3 and the order of the second matrix is 3 into 2. So if you see the number of rows, this is of the form m into n and this is of the form n into m into p. The first matrix is of the form m into p and the second matrix is of the form p into n. So the resultant matrix will be m into n, which is equal to 2 into 2, which is 2 into 2 order matrix. So how do we multiply this? When I'm doing the problems, I'll let you all know. So these are the properties of a matrices. So a plus b is equal to b plus a plus b plus c is equal to a plus b plus c, a plus b dash is equal to a dash plus b dash. K into A plus B is equal to KA plus KB, and you have the other properties which can be proved. If they give you all any matrix to be proven in any of this, it can be proved because it is all the properties of the matrices. This should be kept in mind while we are doing the sums. So first question, if A is, you have your mattress 3 6 0 9 and 4 2 minus 1 5. You have your B matrix which is 6 3 0 9 and 3 minus 3 6 9. And you have your B matrix. So now they are telling us to find B plus A. So first let us write down the matrix as given. So the A matrix and the B matrix. Now they are telling us to find out B plus A. So B plus A is equal to, first write down the B matrix plus A matrix. So now just add, because you have your, the matrix order is what? The matrix order is 2 into 4 and 2 into 4. So it is of the same order, so you can add it. So 6 plus 3, 3 plus 6, 0 plus 0, 9 plus 9, 3 plus 4, minus 3 plus 2, 6 minus 1, 9 plus 5. So you're just adding the matrix. So the resultant figure of the matrix will also be of the order 2 into 4. So 6 plus 3 is 9, 3 plus 6 is 9, 0 plus 0 is 0, 9 plus 9 18, 3 plus 4 7, minus 3 plus 2 minus 1, 6 minus 1 5, 9 plus 5 is 14. So the B plus A matrix is found out. Moving on to our next question, which is, if A is given, the matrix is given for A and the matrix B is given, find A plus B. So we will take what is given in the question, then A plus B. Now they are telling, first you're supposed to add A plus B. So first you take down the A matrix, then you add your B matrix. So just add each digit. 3 minus 5, 6 plus 3, 1 plus 0, 9 plus 0, minus 9 plus 2, 0 plus 0. You get your resultant figure to be your final answer. A plus B is equal to minus 2, 9, 1, 9, minus 7 and 0. So your next question is, if A is given, the matrix for A is given and matrix for B is given, find A plus B the same way. So the order of the matrix is same, so you're just supposed to add each number to the other number in the other matrix and you get your resultant matrix. Since it is A plus B, you first take the A digit and then you will take the B digit elements. So now our question 4, find A minus B if A is equal to and B matrix is given. So now you will take the A matrix, we'll take the B matrix. Now A minus B we are supposed to find out. So we minus each element with the other element in the other matrix. So A minus B is equal to 1 minus 1, 2 minus 2. So since they have already in minus sign, you have your minus sign outside and you have a inner minus sign which is for the element. 3 minus into minus 3 and 4 minus 4. So the resultant figure will be 1 minus into minus plus, so 1 plus 1 is 2. 2 minus into minus plus, 2 plus 2 is 4. 3 minus into minus is plus, 3 plus 3 is 6 and 4 minus 4 is 0. So the resultant figure of A minus B matrix is 2, 4, 6 and 0. 2, 4, 6. The resultant matrix of A minus B is 2, 4, 6 and 0. So your question, next question. So if they have given the matrix A, matrix B and matrix C, you are supposed to find out A plus B plus C and A minus B plus C. So whatever order we are finding out, you will put the matrix in the same order. First, let us find out A plus B plus C. So first you're supposed to put the matrix of A, then the matrix of B, and then the matrix of C, because the order is A plus B plus C. So now you will add each and everything. So 1 plus 4 plus 2. So we get the first element. 5 plus minus 2 plus 3. We get the second element. And 6 plus 3 plus 1. We get the third element. So like that, if you keep adding for everything, then the resultant matrix is 7, 6, 10, 8, 11, 16, 14, 23, 20, which is nothing but A plus B plus C. So now A minus B plus C matrix. So first you put the A matrix, minus sign in the center, then your B matrix, then your addition sign, then your C matrix. So 1 minus 4 plus 2. So you come with the sign correctly. 1 minus 4 and plus 2 with the first digit of every matrix. So you go element by element. So the first element, the second element, and the third element. First element of first matrix, first element of second matrix, and first element of third matrix. Like that you will go element by element. So if you do, so everything is minus. So A minus B plus C. So 1 minus 4 plus 2, 5 minus, so if you see here it is in minus 2, so it will become plus 2 plus 3. So you will minus and add respectively. So the resultant matrix is minus 1, 10, 4, 8, 13, 12, 20, 15, 10. So which is nothing but A minus B plus C. So your next question. So they have given the first matrix plus 2 into the second matrix, minus 3 into the third matrix. You are supposed to evaluate. So let us start with that. So first matrix, which is 1, 3, 5, 2, 4, 6 plus 2 into 0, 1, 2, 3, 4, 5. So let us first multiply the second matrix with 2. Okay, so 2 into 0 is 0, 2 into 1 is 2, 2 2s are 4, 2 3s are 6, and 2 4s are 8, and 2 5s are 10. So that is your second matrix which we got. So your third matrix is 3 into the third matrix. So let's multiply 3 into the elements of the third matrix. 3 9s are 27, 3 8s are 24, 3 7s are 21, 3 6 are 18, 3 5s are 15, and 3 4s are 12. So we have the 3 matrix which is in order. So now you're supposed to add the first 2 matrix and minus the third matrix. So we'll go with the same order. So 1 plus 0 minus 27, 3 plus 2 minus 24, 5 plus 4 minus 21, 2 plus 6 minus 18, 4 plus 8 minus 15, 6 plus 2 minus 12. So you get the resultant figure to be minus 26, minus 19, minus 12, minus 10, minus 3, and 4. Now let us look into our next question. Solve for A and B if 3A plus 2B is equal to and 2A minus 3B is equal to. They have given the matrix. So you're supposed to find out the value of A and B. So let us take the first equation, which is 3A plus 2B as equation 1 and 2A minus 3B as equation 2. So in order to cancel one of the equation, you need one of the variable. So you need to have the same number. So let us multiply the first equation with 3 and the second equation with 2, so that we get the number to be 6. Okay, so that we can cancel it and we can find out the value of one digit. So when we multiply it, we get the resultant figure to be 3 into 3 9, 3 into 2 6, and 3 into 21 63. So you multiply all the digits in the matrix. So when you multiply the second equation with 2, so the resultant figure you get 6b and 6b gets cancelled, plus and minus. So 4a plus 9a is equal to 13a, and the resultant figure is, when you add, you're supposed to add it because it is an addition. 63 plus 24, since it is in minus, you have it as minus 24. 48 plus minus 22, 3 plus 10, 6 plus 2, 6 plus minus 32, and 36 plus 16. So when you add and subtract respectively, you get the matrix to be 39, 26, 13, 65, minus 2, and 52. So we have 13a. When it moves to the other side, it will become in division. Okay, since it is in multiplication. So 1 by 13 into the matrix. So 39 divided by 13 is 3, 26 divided by 13 is 2, 13 divided by 13 is 1, 65 divided by 13 is 5, 26 divided by 13 is minus 2, 52 divided by 13 is 4. So your resultant figure, which is nothing but your matrix A, is 5, 2, 1, 5, minus 2, and 4. So now we have the matrix A, so we can substitute the matrix A in any of the equation. Here we'll substitute matrix A in equation 1. So the equation 1 is 3A plus 2B into the matrix is equal to the matrix. So 3 into A, substitute the value of the matrix A. 3, 2, 1, 5, minus 2, and 4 plus 2B is equal to the resultant matrix. So 2B is equal to 3 into 3 is 9, 3 into 2 is 6, 3 into 1 is 3, 3 5s are 15, 3 into minus 2 is minus 6, 3 into 4 is 12. So when it comes to the other sign, it will come in minus sign because here it is in plus. So 2b is equal to the resultant matrix minus your A value matrix. So 2b is equal to 12 minus 9 is 12, 21 minus 9 is 12, 16 minus 6 is 10, 1 minus 6, 1 minus 3 is 2, 21 minus 15 is 6, 2 minus 6 is 8. So 2 minus into minus plus, which becomes 8. 2 plus 6 is 8. 12 minus 12 is 0. So the value of the matrix B is, when it comes to the other sign 2, it becomes in division. So 1 by 2 into the matrix. So 12 divided by 2 is 6, 10 divided by 2 is 5, minus 2 divided by 2 is minus 1, 6 divided by 2 is 3, 8 divided by 2 is 4, 0 divided by 2 is value. Any value, number 0 divided by any number will be 0 itself. We got the matrix A and the matrix B. So moving on to our next question. If A is equal to, they have given the A matrix, show that A transpose, the whole transpose is equal to A. That is what we are supposed to prove. So A is equal to 2, 7, 3, 4, minus 5, and 6. So A transpose is equal to, so how basically we will do the transpose is basically your rows is turned out to be the columns and your columns are turned out to be the rows. So a transpose matrix is basically obtained by interchanging its rows and columns. So the rows are changed into columns and the columns are changed into rows. So 2, 7, 3 is your row to be changed into column as 2, 7, 3 as a column, and 4 minus 5, 6 is your second row, which will be changed out to be your second column, 4 minus 5 and 6. So this is nothing but A transpose. Now you're supposed to find out A transpose into transpose. So now here again we're supposed to change this into the transpose. So 2, 7, 3 which 2 4, which is a row, will be changed out to be the first column, 2 and 4. 7 minus 5, which is your second row, will be changed out to be a second column, 7 minus 5. 3 and 6, which is your third row, will be changed out to be your third column, which is 3 and 6. So if you see, A is equal to A dash the whole dash. So your next question, so now when we found out the 5A the whole transpose is our first part 1, and now they are telling us to find out the A transpose, 5A transpose. So let's find out the A transpose first. So 1 2 and 1, which is our first row, will come our 1 2 3, which is our first row, will become our first column, 1 2 3. So 2 4 6, which is our second row, will become our second column, 2 4 6. So third row, 1 2 3, will become our third column, 1 2 3. So now you're supposed to multiply 5 into A transpose. 5 into 1 5, 5 into 2 10, 5 into 1 5, 5 into 2 10, 5 into 4 20, 5 into 2 10, 5 into 3 15, 5 into 6 30, 5 into 3 15. So which is our second matrix. So equation, so which is to second equation. So first matrix and second matrix is equal. Therefore from 1 and 2 we find out 5A the whole transpose is equal to 5A transpose. So moving on to our next question. So if A, they have given the matrix A, prove that A square minus 4A minus 5I is equal to 0. First let us find out A square. You have the A matrix given. A square is equal to A into A. So A matrix in again A matrix. So how will basically we will do the multiplication is, the first row into the first column will be your first element. The first row into your second column will be your second element. The first row into your third column will be your third element. So you will go row by row and we'll multiply each column with every row. So 1 into 1 plus 2 into 2 plus 2 into 2, which is our first element. So 1 into 2 plus 2 into 1 plus 2 into 2, which is our second element. So 1 into 2 plus 2 into 2 plus 2 into 1, which is our third element. So when we start multiplying like that and we add finally, which is 1 ones are 1 plus 2 twos are 4 plus 2 twos are 4. So we will add for each thing. The resultant figure that we are getting is 988898889. So the A square we have got. Now let us find out the 4A. 4 into the matrix A. 4 ones are 4, 4 twos are 8, 4 twos are 8, 4 twos are 8, 4 ones are 4, 4 twos are 8, 4 twos are 8, 4 twos are 8, and 4 ones are 4. So you got your 4A matrix, multiplying the matrix A with 4. And 5I we are supposed to find out. What is a I matrix? Which is nothing but a unity matrix, identity matrix, wherein the diagonal will be 0, diagonal will be equal to 1, and the other elements will be equal to 0. So 5 into the 5 into the identity matrix is equal to, only the diagonal element will be 5. 5 ones are 5. The other elements will have 0, because any number multiplied by 0 is a 0. Now we have found out A square minus 4A minus 5I. So put the matrix in order accordingly, and we will minus 9 minus 4 minus 5, 8 minus 8 minus 0, and 8 minus 8 minus 0. So when you start minusing everything, so the resultant matrix is equal to 0, because every element in the matrix is 0. So therefore A square minus 4A minus 5I is equal to 0. Thank you everyone.